Hello everybody, Professor O'Hara here with the practice quiz number 5 for your upcoming Friday quiz. So these are my video solutions. Of course, if you are not interested and you just want to compare your answers to mine, once I'm done marking up my document, I'll be uploading that to the resources tab like I do every other file that I think is of interest to you guys. Okay, so quiz 5, it's got 6 questions, and yeah. 5 of them are multiple choice, and then we've got one written one, so we'll take careful steps to get full marks on that. Alright, so question number 1 in this video, and question number 2 in the next, and so on, as we keep doing. Question number 1, calculating the area under x cubed over 2 to 3, so that closed interval, by first principles, which of the following gives xi and delta x. So these are quite specific formulas that we should remember. We wrote them a whole bunch in class. And this is a question that has to be done by first principles. And I like throwing a question like this out there. I could just do a plain old, compute this area under a curve by first principles. But for people who've seen integral calculus before, they know the faster way to do that. That puts the students who are learning this for the first time or can't remember things at a disadvantage. But by specifically referencing formulas from first principles, everyone is on the same playing field. So I like a question like this. All right, so we have to remember, what are our formulas? In fact, what are these xi's and everything like that? So a brief rundown, just to remember. We're trying to compute areas under curves. And over closed interval, say a to b. Now in this case, a is going to be 2. And b is going to be 3, because we're going over 2 to 3. Okay. All right. But what we're doing is we are approximating this area by rectangles. And so we're trying to add up all these rectangles and figure out all their areas in a very nice logical fashion. And how do we do that? Well, we've made some assumptions. One, that all the rectangles are going to have the same width, and that width we call delta x. Okay, so however many rectangles we've got, that's going to be delta x, and delta x is always b minus a over n, the number of rectangles we've got. What we're doing is we're dividing the length between a and b into n equal parts, because if we've got that many rectangles, then that gets us the width. Okay, now what about these xi's? What are the xi's? Well, they're actually little corner points here. They're bottom corners of our rectangles. And what we do is we plug them into f to figure out how high up our rectangles should be. Because we've got the width, we just need the height, and then we can talk about area. And then we can add up all the areas for these rectangles. That's the whole point of what we've been doing for the last few classes. And so the first corner of a rectangle we come across, we call him x0. And he's just going to be the same as a. And then the next one's x1, x2, and so on. So starting at a, how do I find the x1? I move over by a width. How do I find x2? I move over by 2 widths. And so the formula, which we may remember from class, a plus I delta x. Okay? So here are both the formulas. We either remember them or we reason them out by remembering what we're doing with rectangles and trying to answer the area problem. Okay, well, we're talking about x cubed over 2, 3. All right, so my a is going to be 2, my b is going to be 3. And so what does that tell me when I plug in my formula for delta x? 3 minus 2 all over n is 1 over n. And if we take a look at the possible answers here, we have a few that have delta x are 1 over n. For example, b and c, they both have it, whereas e doesn't, d doesn't, and a doesn't. So that's actually narrowed it down to 2 possibilities. Is it c or is it b? Well, we can figure that out by now figuring out the xi formula. Now, xi is a, which is 2, plus I times delta x, which we now know is 1 over n. Do we see a formula that is 2 plus I times 1 over n? Indeed we do, over here. And so C is going to be our final answer. Okay? Up next will be question number 2. I will see you guys in that video.